Math 3 Lesson Summary Video. Some of this, some of that. This lesson is a develop understanding task, which is meant to introduce you to a concept, but not necessarily finalize rules or strategies. The purpose of this lesson is to use prior knowledge of functions to develop and understand piecewise functions, and introduce formal notation for writing and evaluating piecewise functions. As you start the lesson, you are presented with a situation. Here you have a graph. Create a story that matches the graph below. Label the axes and be as specific as possible in describing what is happening to connect your story to the graph. This is a very open-ended situation. Notice that they didn't even label the x-axis with numbers. They wanted to leave it wide open so that you could come up with any story that you could possibly think of. There are, however, some key features of the graph that we need to remember from Math 1, Math 2, things from our past courses that help us to tell our story. For starters, you need to notice that all of the pieces of this graph are linear. They're straight lines. They have a constant rate of change. That's the distinguishing characteristic of linear functions. And so that means that whatever is happening in your story needs to be changing at a constant rate. Other things you want to remember are that horizontal lines are the constant function, meaning that they don't have their rate of change is 0. They're not changing. So whenever you have a horizontal piece to the graph, that means that something is staying the same. Other things to notice is that we have one piece of our graph that is steeper than another piece of our graph. So whatever is happening in this section of the graph is happening faster than whatever is happening in this section of the graph. Other things that would also need to be in your story is noticing that whatever is happening in this piece of your graph, it has a negative slope. Remember, we refer to the rate of change as slope, and its slope is negative. So whatever has happened in your story, it's now getting less. It's diminishing. It's getting smaller. And that could be any number of things for your story. Last but not least, we also want to notice that we start at 0. Notice the y value here is 0. The x value is 0. That's how I know it's the start. So we're starting at 0, but we don't end at 0. The y value over here is 10, and so that's ending at 10. If you were to write a function to match each part of your story or section of the graph, how many would you write? Here you need to notice how many pieces are there to this graph. When we think about pieces, we want to make sure that we realize that it is all one function, but there are some distinct pieces to it. You may notice that for this domain, we have this piece. For these x values, we have this piece. For these x values, we have this piece. And for these x values, we have this piece. So that is a total of 4 pieces of our story. So if I was going to write a function or an equation for each piece, I should have 4 equations. Now, how would I actually go about writing those equations? That's what, if you flip over to the next page, it actually wants us to write those equations. So I do need to stop and think about how would I do that? So reach back, Math 1 knowledge, Math 2 knowledge. How am I going to write an equation for this line? Things that you want to remember. Usually we like to have the slope and the y-intercept. Slope should not be a problem. I'm going up 2 and over 1. So up 2 over 1, that gives me a slope of 2. But I don't know its y-intercept. The line doesn't continue on. The graph kind of runs out of room here. I don't know what my y-intercept is. If I dig deep though, and I go to Math 2 where we learned transformations, if I have the equation y equals 2x, because it's got a slope of 2, but I don't want it to start at 0, 0, I want it to start at 10, 5. I can translate it to the right 10 spaces. If you remember from our transformations, to move right, we have to subtract inside the function. I can also translate it up 5 spaces. And if you recall, outside the function, if we add, that's what translate things up. So I can, instead of starting at 0, 0, start at 10, 5. Another name for this form, for this transformation form, is point slope form. So moving on to the next page, up at the top, you see where we actually need to identify and write the function for the corresponding sections of the graph. If you can see here, this notation is new. This is a formal notation for what we call piecewise functions. All right? A piecewise function is a function that is made up of many pieces of other functions. And because it's made up of pieces, we need to give it 2 pieces of information. What is the piece? What is the function? What is its equation? And when do I use that piece? So if you recall, we talked about that each of those sections used particular x values. So if we go and look at the piece we just did the equation for this piece right here. We found its equation. And we said that it went from 10 to 15. So the section for it is 10 to 15. So we're going to want to remember that. We found the equation for this section, and it goes from 10 to 15. So in our formal notation, the way that would show up in our formal notation is that we would write the sections. Now, one section went from 0 to 5. One section went from 5 to 10. One section went from 10 to 15. And one section went from 15 to 20. Now, the one that we actually wrote the equation for, we said that it was 2x minus 10 plus 5, because we used the transformations in our point slope form. Notice I didn't write y equals. The reason you don't write the y equals here is we've got f of x. Don't forget, f of x is representing the output. And so y is the output. It's the range. So you don't write the y equals part over here because the y equals part is actually already over here. And so I just had to write this part. You do need to go through and write the equations for the other 3 sections so that you can practice writing equations of lines as well. When you are writing formal notation for piecewise functions, I do want to point out that sometimes this closing bracket is not included. You'll see some books that have that and some books that don't. Some situations that you run into where people do write it and some do not. Both are accepted in the mathematical community. Make sure also that you go back and connect all of this information to your story. Remember, this is what's happening, and this is when it's happening. So from 0 to 5, this is happening. From 5 to 10, this is happening. And you always want to make sure you connect that back to the context of your story. Another thing to remember when you're considering writing your domain, we just wrote this as 0 to 5, 5 to 10. We were thinking about the intervals. But don't forget, we have a couple of formal ways to write intervals. We can use inequality notation to write something like 0 is less than x is less than or equal to 5. This would be one way that I could represent 0 to 5. We also have what we call interval notation, where we use parentheses and brackets to say, okay, this is in between 0 and 5. And remember, brackets include, parentheses do not include. So this is the less than or equal to, the equal to part. But we can use formal notation to also write our domains. Last thing that we want to look into is how we use this function notation. So if you recall from function notation, when we use f of x, whatever we want to be the input to be substituted into our equation, we just put inside the parentheses. It is the input, so it goes in the parentheses. So this function notation is asking me in my equation up above to substitute 12 into the equation. Now, in our particular function, 12 fell into that 10 to 15 range, the 10 to 15 range. And if you recall, 10 to 15 range was the equation that we had figured out for our graph, the 2 times x minus 10 plus 5. That was the equation. Whichever domain the input falls into, it tells you which equation that you're supposed to substitute into. So I'm going to take 12 minus 10, 2. 2 times 2 is 4, and 4 plus 5 is 9. So f of 12 would be 9. Now I can confirm this by going back to our original graph. When we go back to our original graph, don't forget how to evaluate functions on a graph. Remember, x is the input, so first I would need to find 12 as my input. And if I go and figure out where does my actual function cross 12, it appears to be at the point 12, 9. So when the input is 12, the output is 9. Don't forget, you can evaluate functions, whether they are in table form, equation form, graph form. These are all multiple representations, but they're still functions and they can still be evaluated. So make sure that you practice evaluating this function in all of these different circumstances.